Hi everyone, welcome to another Gaffer in Gear. In today's episode, it's a gear review and we're having a look at the Soonwell tubes. So these tubes are 80% brighter than any other tube that I own. They boast an IP65 rating, so you can use them out in the rain. They have DMX capability and they have very good color render and CCT accuracy. However, they do have some problems that you need to know about, so let's watch the review. Alright, so let's quickly go over the capabilities of these units before we get into the pros and cons. Alright, so they are RGBWW light engines. They are very bright. We'll talk about that later. Way brighter than any other tube I've come across. They have a standard CCT range from 2600 Kelvin up to 6000 Kelvin with a very impressive color render. So with the exception of the bottom 3 Kelvins, all of the rest of the Kelvin range in that mode scores a TM30 of 96, which a lot of manufacturers would be jealous of. It's got very, very good CCT accuracy in that mode. It also has an extended CCT mode, which uses the color emitters to try and extend the range, and that goes from 1600 Kelvin up to, they claim, 20,000 Kelvin, but it doesn't get to 20,000, it only gets a bit above 16,000. But that mode has very weak color render scores and the white point accuracy is all over the place. The units have DMX and they are weather resistant. They also have all the color modes you'd expect from an RGBWW light, such as HSI, XY coordinate values, and they have a massive Lee gels inventory. Okay, so let's go through the pros with these, and it's quite an impressive list of pros. So the overwhelming pro for me is the brightness. So this comes in at 88% brighter than a Nanlite Pavo tube and 81% brighter than a Titan tube. The next positive for me is in the CCT mode. The color render is amazing and the CCT accuracy is very, very good. The next thing is the DMX. So it has DMX capability. You do need adapter cables because the tubes being smaller than standard XLR connectors, you can't use a standard XLR, so you need an adapter cable. The next positive is these have an IP65 rating, so you can use them outside in the rain without a problem at all. The next plus, and this is I think a big plus for this unit, is it has affordable removable batteries. So if you only want 1 or 2 of these lights, so for example that's me, I only want 1 or 2 of these because of the brightness, I'm not that impressed with a lot of other things. If the battery goes flat, I just need to replace the battery. So the battery's quite affordable. I don't need to buy a kit of these just for, you know, when batteries go flat. So that for me is a massive positive with these units. The next positive is the build quality. So the build quality is quite impressive. It's got a metal back. Now the metal back, I'm guessing, is also the heat sink. Now, interestingly enough, when I was testing these to see the battery run times, this unit runs very cold, but the smaller unit runs quite hot. So if you're running it at full brightness for 3 hours plus sort of thing, you're definitely going to want gloves if you're hand holding the small unit, but the big unit seems to run nice and cool. Okay, it comes with a decent amount of accessories to get you started. We'll cover that later on in what you get. And the other plus for me is the front diffusion. So it's got a very even front diffusion. You can't make out the pixels if you're shooting into them. Now, if you're impressed by the positives, chances are you're going to be equally as unimpressed by the negatives. So the first negative for me is really disappointing, and that is how the unit generates its colors in the color modes. So the color modes are your HSI mode, your gels library mode, RGB mode, and your XY coordinate mode. Unfortunately, these tubes generate their colors using only the RGB color emitters. They don't use the warm white or the cool white. So if you're using full saturated colors, that's okay. But if you're desaturating it, it desaturates to a really bad RGB mix. Now this desaturation point's at around 11,000 Kelvin and the white point is nowhere near the ballpark. And the color render is terrible on this desaturated white point. The next negative for me is to do with the DMX. You require a DMX adapter cable, and like a lot of manufacturers, they've made their adapter cable what I'd consider to be far too long. So trying to conceal this cable would be an absolute nightmare if you're using the tube, say, on a wall and you just want to hide a Lumen radio receiver. The The next negative for me, and I could be wrong on this, is it seems that you need a receiver transmitter box in order to use these tubes via the phone app. I couldn't get the phone app to work on my Android phone directly to the tubes. Now, maybe it's not a negative for you, but one thing I do think is a negative with these is if you're running them off AC power, you can't simultaneously charge the battery inside. The batteries only charge externally from the tubes. Now, the next negative for me is to do with running these off AC power. As soon as you connect the AC power, the light turns on. But this isn't my negative. The on-off switch on the back of the light doesn't seem to work when you're running in AC power. The only way you can seem to turn the tube on and off is to connect and disconnect the power supply. Now, the next negative is to do with the plus-minus green in the CCT mode. The plus-minus green doesn't seem to be connected to the white light. So what I mean by that is if you dial in plus-minus green and then dim the light down, your plus-minus green level stays the same, or your green level stays the same coming off the green emitters, but your white light fades, giving you a very green light. So I'm just going to show this to you here. I'm going to add in some plus green. I'm going to add full plus green. And now I'm going to fade the light down. Okay, so let's start fading it. And the light gets greener and greener as I fade. Now, the next thing that could be a negative for you is the actual shape of the tube. Because it has removable batteries, it is not circular. It is also way bigger than a standard T8 or T12 tube, so your existing gripping won't fit it, which is why they come with their own clamps. Okay, so let's go through how much this all costs and what you get for your money. So we're going to start off with the 4-foot unit first. So this sells for about $500 US. I can't find an Australian price anywhere for it. Now, this is called the ST50. So 50 is for 50 watt. ST stands for Sensei tube. So they're going with a martial arts theme. So you get a very well constructed bag. You get a shoulder strap for the bag. You get an AC power lead, what's this called? IEC power lead. Now, the IEC power lead is to plug in your battery charger because the batteries charge separate to the tubes. In the other compartment, you get an AC power lead. So that just plugs straight into your power outlet, and the other end plugs straight into the tube. There's no transformer here, no power supply. So these can run, the 4-foot tubes, can run directly off AC power, and it's universal power, so it doesn't matter what voltage you are or what power frequency. You get the tube. Now, the tube does have these grooves on the back, which are for your mounting clamps, which we'll get onto in a sec. So you get 2 of these mounting clamps. So these mounting clamps go onto the back of the tube very simply. Simple as that. Now, if you want to, you can use them in this configuration because that thread does take an industry spigot. So you could mount it to the rest of your grips equipment like this. However, you do get some other bits and pieces. So I'm going to call this the IKEA grips kit because it flat packs. So you get a plate and you get some nuts, bolts and screws which come in a bag. All right, so you get a spigot that mounts to the plate. Allen key, that's why I'm thinking it's like IKEA. And now you can mount your clamps, your 2 clamps, to this plate. So now you can use this to mount the tube more securely to something like, say, a C-stand. Now, if you want to mount it onto a light stand, they have an adapter here to go from the spigot point here to the top of a light stand. Now, they also have this brace for the bottom, so I'll just put that on. So you remove one of your clamps and put the brace in its place. Now, this bracket piece has a thread at the bottom. Now, that thread can connect into the floor stand or turtle that you get. Now, the turtle is quite well built. It's actually metallic or aluminium, and it's got plenty of points here for spigots. Where did I put the spigot? Anyway, trust me, spigots connect into there. Now, you can mount this plate to the turtle. And I'm just going to show you with the smaller tube because it's easier to demonstrate. The tube now mounts onto the clamp. So you've got your floor base. Now the one thing I almost forgot is you get a battery. Now the battery doesn't charge in the light, it has to be plugged into the external battery charger. Now when you're charging, you get indicator lights here to tell you your status. Now I almost forgot, the battery life on the large tube is 1 hour and 50 minutes. Now that's with the light running at 100% brightness at 5,600 Kelvin. All right, so let's have a look at the smaller kit now. So it's quite a bit different. So again, it comes in a well-constructed bag, but you don't get as many bits and pieces. All right, so let's have a look in the top. You get a strap for carrying the bag over your shoulder. You get an IEC power lead. Now here's where things are a little bit different. The IEC power lead plugs into the charger, but the charger is also your transformer. All right, so I'll explain what I mean by that. So if you want to run this off AC power, you plug the transformer into the light. Okay, pretty straightforward. Now if you want to charge the battery, you have to take the battery out of the light and plug the battery into the transformer. So this is also your battery charger. So here's the problem. You can charge your battery or you can run the light with this. You can't do both at the same time. Now the battery runtime on this unit is 3.5 hours, and that's at full power with the light running at 5,600 Kelvin. You get the tube, of course. You get one clamp, and you get a ball mount. And that all sells for $300 US. Now separate batteries sell for about $80 US. Okay, so let's go very quickly through operating the light, and it really is quite simple to operate. Now to turn it on, you press down the button at the end here and hold it down. Now it tends to turn on with the screen upside down sometimes. So this time it made a liar out of me, but if it does that, what you want to do is turn it off, get it orientated exactly the way you want it to run, and then turn it on. Because the screen can operate the correct way up and upside down, but it doesn't automatically flip when you're using the unit. All right, so we're in our CCT mode at the moment. Now we can select our mode of operation by pressing the button here. So press the M button. So that's gone down to dim. If I press it again, it'll go to CCT. If I press it again, it'll go to plus minus green. If I press it again, it'll go back up to the operating mode that we're in. So to change what you've got selected, press the arrows back and forth. So at the moment we've got CCT selected. So I'm going to go down to CCT, and then I'm going to use the arrows to adjust our CCT. So as you can see, they're very straightforward. It adjusts in 100 Kelvin increments. If you hold your finger down, it goes very fast. Now let's go to our next mode of operation, and I'll just press the M button until the mode is selected. And let's go to HSI, hue, saturation, and intensity. So let's say I want to change our saturation, for example. I just press the M button until I get to saturation. Then I can increase or decrease my saturation using the arrow buttons. Okay, so let's say I want to change the hue angle. I just scroll through pressing the M button until I'm on the HSI, and I can change the color hue or the color angle it's running at. All right, let's go to our next mode. Okay, so the next mode is XY coordinate value. Let's skip to the next mode. Next mode is CCTS. So this is our extended CCT range. Now using this mode, you can go to a lower Kelvin or a higher Kelvin than you could in the basic CCT mode. But there is a little bit of a catch. It doesn't go through the whole range of the Kelvin. It only goes through the differences. So it'll go from 1,700 Kelvin up to 2,600 Kelvin, and then jump all the way up to 6,100 Kelvin. So it skips all the Kelvin that's in the normal CCT mode. Okay, so let's go to our next mode of operation, and that is RGB white. So I won't go through that, that's pretty straightforward. And the next one is set colors. So I'll just show you through this. So you've got some pre-programmed colors in the unit to help you select a quick mode of operation. So yeah, basic fast color mode. Now our next mode is our gels library, which is Lee color gels, and we literally have hundreds of gels to choose from. Now, as I said earlier, they're only rendering using the RGB color emitters, so they're not as true as a real gel would be on a light, for example. So they're okay for backgrounds. I don't know if I'd use them on someone's skin tones. You might not make friends with a makeup artist if you do that. Okay, let's go to our next mode. So next mode is special effects. So we've got a few special effects here. So we've got a white cycle. We've got a warm cycle. Got CCT jump. Got CCT cycle. HSI cycles, that's just like a color chase. And we can do things like set our speed. So let's speed that up so you can see what it's doing. Next effect is HSI jump. We've got welding flash, explosion, fireworks, faulty bulb or bad bulb, and party. Next is the save menu, so you can save and recall settings. And then you've got your menu where you can select your Wi-Fi on-off or change your DMX address. All right, let's have a look at the DMX, but before we do, I'll just run you through how I've got it set up. So I'm running Lumen Radio to a Lumen Radio receiver, which is on the box there, and that's being fed via cable into the light. Now I've got it set up like this so you can see a limitation of it. So if you're running it on the floor stands, the DMX feeds into the top, so it makes it very hard to conceal your cables if you're trying to get a nice slick look. Now the DMX adapter cable goes to 3-pin. So I've got a 3-pin to 5-pin adapter and then into the receiver. Now, the reason I'm running it to the receiver is so you can see a worst case scenario in terms of how it dims, because Lumen Radio only works at about a 45 Hertz refresh rate compared to some desks that run at thousands of refresh rates a second. Now, in terms of that, it doesn't matter if you're running it from the Lumen Radio receiver or hardwired into the console here, you get the same result either way. Okay, so let's get into talking about the DMX now. It's a 6-channel profile. Channel 6 selects what mode you're running in, and you've got a choice of CCT, HSI, XY, CCTS, RGBW, Gels Library, which is all these, effects, and you've also got set colors. So channel 6 selects which mode you're running in. Now, in terms of things I don't like in the CCT mode, channel 3 selects your plus minus green, but 0 isn't off, and strangely enough, 40% is 0 plus minus green, so that's something that might trip up desk operators with it because it doesn't tie into any standard. But one thing I do find interesting is the HSI mode, so we'll just swing over to that. Now I'll just get channels 2 and 3 down to 0. Now channel 2 selects the start of your hue colors, so I'm just going to go through channel 2. And we're changing our color hue. And once I get to the top of channel 2, I then go to channel 3, and that takes over. Okay, so what that means is you can select, because it's using 2 channels for the hue, you can select all 360 colors that are on your color wheel. So normally with DMX on an 8-bit profile, you can only select 256 colors. It tends to skip colors. So that's sort of a plus. All right, so let's get into testing it now. So I'm going to look at it in the CCT mode. And we're just going to have a look at how quickly it turns on and off. So this is a 0-second on-off command, or instant on-off command. Now, as you can see there, it doesn't instantly go to black. It's got a very, very quick fade. All right, let's program in a 5-second fade to black. Now, it is a little bit jittery at the end. It might not show up on my camera. It's a little bit steppy. It's pretty smooth. The fade up, though, look at that. The fade up is really smooth. Very, very smooth fade up. Again, the fade down, it's not perfect, but it's better than a lot of lights that are out there. Really surprising for the price. It's not too bad. I reckon you could get away with that. But again, the fade up, that is just so smooth. I'm really surprised for the price point. All right, let's program in a 2.5-second automated fade now and have a look at that. So this is 2.5-second fade to black, 2.5-second fade up, Again, the fade up's real smooth. Let's go to 1 second now. Okay, and fading down. 1 second fade to black. 1 second fade up. Okay, let's program in a half-second automated fade to black. And fading to black. And fading up. Now let's do a change of CCT. So we're at 5,600 Kelvin here. This is 3,200 Kelvin. So this is an instant command change. And as you can see, it doesn't change instantly. There's, I'm guessing, about a half second, or maybe a quarter second switch over as it does it. So it doesn't do an instant change. Let's do a 5 second automated CCT change. So from 5,600 to 3,200. That's very smooth. That's very smooth for the price. All right, let's have a look at the same thing going the other way. 2.5 seconds. Okay, that's very smooth. So you could use this for transitions on your set. Let's have a look at now 1 second. And let's go. So switching over to tungsten in 1 second. And we'll switch back the other way to daylight. 1 second automated transition. Very smooth. And let's now have a look at a half second transition. So I've got to say, particularly for the price point, I'm really impressed with how this responds to DMX. Okay, let's go through all the data I've collected, starting off with CCT accuracies. Between 2,600 and 4,000 Kelvin, it was accurate to plus or minus 28 Kelvin. Between 4,000 and 5,000 Kelvin, it was accurate to plus or minus 40 Kelvin. Between 5,000 and 6,000 Kelvin, it was accurate to plus or minus 61 Kelvin. In the CCTS mode, between 1,600 and 2,500 Kelvin, it was out by on average plus 40 Kelvin. Between 6,000 Kelvin and 20,000 Kelvin, the range it was out by was between 266 Kelvin to 3,395 Kelvin. The higher the target Kelvin value, the more it was out by. Now let's take a look at the color render results. In its standard CCT mode, it has very respectable color render scores. At 2,600 Kelvin and 2,700 Kelvin, it scored a 94. At 2,800 Kelvin, it scores a 95. And across the rest of the range, which is 2,900 to 6,000 Kelvin, it scores 96. In the CCTS mode, the lowest score is at the lowest Kelvin, 1,600, where it scores a 73. The color render scores creep up until you get to 2,100 Kelvin. From 2,100 Kelvin onwards, it scores 90 plus. Now let's take a look at the white point accuracy measured in delta UV. Between 2,600 Kelvin and 3,000 Kelvin, the higher the Kelvin, the more accurate the delta UV is. The range is plus 0.0050 to plus 0.0014. Between 3,100 Kelvin and 4,000 Kelvin, the light is very accurately tracking the Planckian curve, with a delta UV of only plus or minus 0.0005. Between 4,100 Kelvin and 4,900 Kelvin, the light is again very accurately tracking the Planckian curve, with an average delta UV of plus 0.0005. Between 5,000 Kelvin and 6,000 Kelvin, the white point jumps up to the daylight curve, with an overall average of plus 0.0039. In the CCTS mode, the white point is not very accurate. With the lowest CCTs, between 1,600 and 2,500 Kelvin, the light starts out very magenta at minus 0.0074 and finishes slightly green at plus 0.0033. Above 6,500 Kelvin, there's quite a bit of range. The most the delta UV was out by was at 8,000 Kelvin, where it came in at plus 0.0119. Surprisingly, it was at its most accurate at 20,000 Kelvin, where it came in at plus 0.0013. Now let's have a closer look at some of our CCTs, starting off with the lowest CCT we can dial in using the CCTS mode, and then we'll have a look at the lowest CCT we can dial in using the standard CCT mode. When I dialed in 1,600 Kelvin, I got 1,608. Now the color vector is way out. It has an average color accuracy of 73% and an average color saturation of 120%. Here is the spectrum distribution, and the white point came in with a delta UV of minus 0.0073. When I dialed in 2600 Kelvin, I got 2660. The TN30 color vector scores were 94% average color accuracy with a 97% average saturation. All of the CRI scores are above 90%. It has a very healthy spectrum distribution, and the white point came in at plus 0.0050 delta UV. When I dialed in 3200 Kelvin, I got 3209 with an SSI score of 86. Color vector testing suggests a more realistic score of an average 96% color accuracy with a 102% average color saturation. Here are the CRI scores. Only R11 is below 90%. The spectrum distribution is quite healthy, and the white point is really accurate with a delta UV of plus 0.0005. When I dialed in 4400 Kelvin, I got 4436. The color vector scores, 96% average color accuracy with an average 103% saturation. Here are the CRI scores, and only R11 is below 90. It has a nice meaty spectrum distribution, and the white point was quite accurate with a plus 0.0005 delta UV. When I dialed in 5600 Kelvin, I got 5684 with an SSI score of 75. TN30 color vector scores was 96% average color accuracy with an average 102% saturation. Here are the CRI scores, and only R11 is below 90. This is the spectrum distribution, and the white point came in at plus 0.0046, which puts it about a 1/4 correction gel off the Planckian curve and less than a 1/8 correction gel off the daylight curve. When I dialed in the maximum Kelvin, 20,000, I only got 16,605. Surprisingly, the TN30 still comes in with a 90% color accuracy and an average 104% saturation. And when you look at the spectrum distribution, you can see why it still has a good score. And also surprisingly accurate is the white point with a delta UV of 0.0013. Now let's have a look at how accurately these tubes generate a fully saturated color vector. Red, which should be 0 degrees, came in at 1 degree. Green, which should be 120 degrees, was smack on. Blue, which should be 240 degrees, came in at 241. Yellow, which should be 60, came in at 53. But like with all RGB lights, if you want a decent yellow, try dialing in 40. Cyan, which should be 240, came in at 220 degrees. And magenta, which should be 300, came in at 269. Now let's take a look at how this unit desaturates its color vectors. Now normally I give you accuracy results, but this unit doesn't desaturate to any color standard. In the HSI mode, the light desaturates to an RGB color mix, so it's not using any of its broad spectrum white color emitters. This results in a CCT of 10,920 Kelvin. The white point is way off target with a delta UV of minus 0.0311. The color render is terrible with an average 54% color accuracy with an average 135% color saturation. I'm Andrew Locke, thanks for watching Gaffer in Gear. If you're new to the channel, please click like and subscribe. The next episode should be on some new designed Coupeau clamps. Okay, see you later. Take care.